Okay, last lesson of the unit, lesson 12. Given the solutions, write the polynomial equations. Now we're working backwards. So to write a polynomial equation, start by writing the zeros as factors, x minus whatever your zeros were. Then multiply out to get the standard form. So once again, we're working backwards. So if you notice here, there are our zeros. Okay? Yeah, let's do that. Glasses on though. Yeah, let's make it. Those. There you go. That looks good. Alright, so basically our zeros right there are at -2 and +2. Okay, those are the x-intercepts. It's a parabola. Okay, so you can see that there should be two answers, and there are. Since both of these are going through the points, okay, remember, we're talking about through, and through means they have a multiplicity of 1. There is no bounds. So we're going to write these numbers as x minus -2, also known as x plus 2, and x minus 2. We just plug those numbers in to the x minus form. Now we're ready to multiply it out. So take a little space down here and do that. So this is going to be a difference of 2 squared. The middle terms are going to drop out because both parentheses are the same. One's plus, one's minus. So x times x, -2x, plus 2x, minus 4. Those cancel. We get x squared minus 4, and that is our standard form. That's simple. Okay? Now, we have a cubic function. So we look at our intercepts here and here. Now, being that it's cubic, we should have 3. Or remember, right here, we have a bounce, which means multiplicity of 2. Here, we have a through, which means multiplicity of 1. So our bounce is at -3. And our through is at 2. Which means we have x minus -3, which is x plus 3. But we have 2 of those. Okay? And remember, this part right here could be written this way. X plus 3 squared. It's up to you. Either way is acceptable. So now we have to come down here and multiply these out. X plus 3 squared you can FOIL, or if you remember the shortcut, you square the first, you multiply 3x and double 6x, and multiply the square the second. X squared plus 6x plus 9. Now we're going to do that times x minus 2, which means we multiply everything by x cubed, plus 6x squared plus 9x, and then we're going to multiply everything by -2. I ran out of room to draw my arrows, but normally I would draw the lines. So that's -2x squared, -12x, and -18. So I join my like terms. So my factor form is x cubed. 6x squared minus 2x squared is 4x squared. 9x minus 12x is -3x. And the -18 stays. So we just work backwards from our graph and our solutions to the original standard form. Now, understand when we're talking about complex solutions, they always come in pairs. So if we have 2i as a solution, negative 2i is also a solution. If 2 minus 3i is a solution, 2 plus 3i is a solution. That's known as complex conjugates theorem. You're not going to be tested on knowing the name of it, but that's what it's called. So, given the solutions, write the equation in factored form, then write the equation in standard form. So, here we go. We don't need a drawing. These numbers here are the intercepts. Real quickly, 1, 2, 3, if we had it drawn out, and 1, 2. But notice, this is a balance, because there's 2 of them. Okay? So what we do is we write it in factored form, which is x minus 3 and x minus negative 2, which is plus 2 squared. Or we can expand that and say x plus 2, x plus 2. That's up to you. Either way is fine. Whatever way works for you to understand it better. And now what we're going to do is multiply those out. So once again, you can FOIL x plus 2, or the shortcut, square the first, multiply and double, and square the second. And then send in your x cubed, 4x squared, 4x. Send in your negative 3, minus 3x squared, minus 12x, minus 12. Standard form is going to be x cubed. 4 of these, take away 3 of these is 1 of those, x squared. 4x minus 12x is negative 8x. And negative 12 just tags along. There you go. Okay. Hint, write as factors, then FOIL the imaginary factors first. This is kind of important. Don't forget I squared is equal to negative 1. So, example 4, we have 5, 2i, negative 2i. So, factored form first, x minus 5. Then, x minus 2i, and x minus a negative, which is plus 2i. If you remember when we first learned about imaginary numbers and the conjugate theorem, right here is almost like, very similar to, a difference of 2 squares, because we have a plus and a minus. So the middle term is going to cancel out. So we have x squared minus 2xi plus 2xi minus 4i squared. And remember, that's going to end up being negative 1. Well, the 2xi and negative 2xi cancel each other out, which leaves us with x minus 5 times x squared plus 4. Because this is a negative 1, and negative 1 times negative 4 is plus 4. Remember, we have a sum of 2 squares right there. So it's a similar structure to difference of 2 squares, except the I being involved makes it plus. And now we're going to distribute the x and get x cubed plus 4x, and then distribute the negative 5 minus 5x squared minus 20. Remember, in standard form, we need to write it in descending order. So x cubed minus 5x squared comes next, then the 4x, and then the negative 20. Okay, example 5. So for this one, you got to remember that whenever you have an imaginary number, such as 4 plus 3i, you're going to have the conjugate 4 minus 3i. So I would suggest you automatically just write this every time. So for example, if you had 2i, then given, you automatically know you have negative 2i, and so forth. So you have negative 3, so remember it's x minus negative 3, which really makes x plus 3. So that's your first one, x plus 3. Then you're going to have your two kind of longer ones, x minus, be careful here, it's actually going to be another parentheses, 4 plus 3i. So actually you need a double parentheses there. We'll have to distribute this. And then x minus again, because it's always x minus, and then in parentheses 4 minus 3i. Don't know what I did there. You want to make division symbols. 4 minus 3i. Now to finish this off, we're going to just put x plus 3. And we're just going to distribute the negative. Now notice it does say don't multiply out. We're not going to actually do any multiplication except we're distributing the minus sign. So it's going to be actually x minus 4 minus 3i and x minus 4, can't make my x here, plus 3i. And then example 6 is pretty much lesson 11, start to finish, solve the polynomial equation. So this is kind of a review from lesson 11. So we're going to find the solutions to the following polynomial. Since this is a 4, we're going to have 2 real solutions and 2 imaginary ones. Find all possible real zeros. So here's our p. This 1 is our q. So p over q, 24 over 1. Factors of 24 are 1, 2, 3, 4, 6, 8, 12, 24. Factors of 1 are just 1. So it's going to be the plus and minus of all those whole numbers. Plus and minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, plus or minus 24. That's 2, 4, 6, 8, 10, 12, 14, 16 possible real zeros. Of those, maybe 3 or 4 work. You could get lucky by guessing, but remember what we said in lesson 11, go ahead and put this in your graphing calculator. Get a picture of it. See where you see it going through. Because remember, there's only going to be 2 real ones out of those possibilities. Your other 2 are going to be imaginary. So it's a total of 4, but only 2 of those whole numbers are going to work. You want to narrow your possibilities by graphing on the calculator first. So here you go. It's entered into the graphing calculator. You can either look at the table and see there's a 0 at negative 3, and there's a 0 at 2. You can also do that by looking at the graph -3, and 2. So that narrows down where you want to start. So when you're doing your synthetic division, you can use either one of those numbers, -3 or 2. I'm going to do the -3 just for the heck of it. So I have my 1, 1, -2, 4, and -24. Drop down, multiply, add, multiply, add, multiply, add, multiply, add, there's my 0. Now remember, from lesson 11, we want to have 3 numbers and a 0, and we have 4. Now you have 2 choices, which we talked about in the previous notes. You can go ahead and synthetically divide again, and you know the number is going to be 2. You looked at it on your calculator. Or you can write this as, see, we start with 4, x cubed minus 2x plus 4x minus 8, and then factor by grouping. It's your choice. It doesn't really matter what you do. Okay? It may not always factor out, so it doesn't matter. It's your choice. I'm just going to synthetically divide by the 2. Drop down, multiply, add, multiply, add, multiply, boom. I now have my 3 numbers, which means it's going to be x squared plus 4 equals 0. Well, move the 4 over, I get x squared equals -4. And then I get x equals square root of -4, which is then x equals square root of 4 is 2, plus or minus, and I for the -1. Some of you may have seen that this was the difference of 2 squares, sum of 2 squares, and gone to factored form here of x plus 2i, x minus 2i. Same answer. 2 different ways of solving the same polynomial. Factoring it or using the square root property. You're going to get the same answer. So what's the factored form? We have to put it all together. Those 2 and these 2. The 2 real and the 2 complex. So x plus 3, x minus 2, and then you can either write it out as plus or minus 2i, or you can expand it either way. What's the degree? Well, we start off with 4, exponent of 4. Our lead coefficient was 1. That makes it quartic. If you took a look at this, 1, 2, 3, we looked there on the graph, -3 and 2. If we want to get our y-intercept down here, all we do is plug in a 0 for x, which is very easy, because you follow up here, that's 0, that's 0, that's 0, that's 0. That leaves you with -24. You can also go to the table and look for 0 on x and find y of -24. So that's way down here, -24. That's not even the scale. It should be further down. But that's your y-intercept. And actually, it's going to be your vertex. I could have drawn that better, but there's your general shape. So what's the end behavior doing? Well, as it's going left, negative infinity, in the second quadrant, it's going up. And then as it's going right towards positive infinity, in the first quadrant, it's going up towards positive infinity. And last but not least, the solution is multiplicity. Well, -3, 2, 2i, and -2i. Well, -3, it goes through. That's the multiplicity of 1. Same for 2. It's going through. multiplicity 1. And there's no multiplicity for our imaginary numbers. And there you have it.